California's water problem is starkly evident. While the north is drenched in rain, the south suffers from parched droughts. A proposed solution, a $20 billion project involving a 56 km tunnel beneath the Sacramento-San Joaquin Delta, aims to transform the state's water future over the next 12 years. Starting near Hood, 24 km south of Sacramento, this ambitious project will feature intake valves along the Sacramento River, each capable of handling 85,000 liters per second. These intakes will filter water through fine screens to protect aquatic life before channeling it into the tunnel. Large tunnel boring machines will carve through layers of earth, constructing the tunnel with reinforced concrete. Advanced filtration systems will ensure that only clean water flows through, contributing 6 billion cubic meters annually to California's supply. This system can capture excess water during wet periods, stabilizing the supply during droughts. California, a state of contrasts, faces a persistent challenge with water distribution. Northern California, with its vital watersheds, fisheries, and communities, receives much of the state's precipitation. However, climate change and droughts frequently impact this region. Meanwhile, the arid southern portion of the state depends heavily on this water for agriculture and urban use. In the 1960s, Governor Pat Brown recognized the need for a solution, supporting 2 large projects designed to reallocate water from Northern California to the south. Fast forward to the early 1980s, his son, Governor Jerry Brown, proposed the Peripheral Canal, an ambitious plan to transport water from near Sacramento, around the Sacramento-San Joaquin Delta, into the Central Valley Project CVP, and then to Southern California. However, the project failed to gain voter support and was shelved. The CVP, completed in the 1970s, spans about 970 km of canals and moves up to 16 million acre-feet of water annually, primarily for agricultural use. This federal project generates electricity, although about half of it is consumed by the system itself. The State Water Project SWP, conceived in the late 1960s, moves approximately 7 million acre-feet of water annually through 1,100 km of canals. Unlike the CVP, the SWP allocates 75% of its water to urban use and 25% to agriculture. However, it uses more than twice the electricity it generates, highlighting the project's energy demand. Jerry Brown revisited the idea of a large-scale water transfer project during his later term in office. This time, the proposal evolved into the Twin Tunnels Project, part of the Bay Delta Conservation Plan. However, due to concerns from the U.S. Fish and Wildlife Service and others about the project's potential environmental impacts, the plan was significantly scaled back and renamed the Water Fix and Eco Restore Project. The Water Fix proposed constructing 2 massive tunnels, each about 48 km long and buried deep underground. These tunnels would connect 3 intake facilities in the north to the intermediate forebay, then extend to the Clifton Court forebay. The main aim was to make the water conveyance system for the SWP and CVP more reliable while alleviating environmental pressure on the delta. However, despite these modifications, the Twin Tunnels project faced strong opposition and was ultimately stopped in 2018 due to efforts by Delta citizens and various support organizations. By 2022, the project was renamed the Delta Conveyance Project and significantly scaled down to a single tunnel design. This new plan proposed constructing 1 tunnel to transport water from the Sacramento River, bypassing the complex and fragile delta to the Bethany Reservoir, and then into the California Aqueduct. This streamlined approach aimed to address environmental concerns while maintaining the objective of ensuring a reliable water supply for Southern California. Imagine looking at a map of California in the center. You'll see the Sacramento-San Joaquin River Delta, a sprawling network of waterways merging the flows of the Sacramento and San Joaquin rivers. This estuary, covering around 2,850 square km, is crucial, supplying water to about 60% of Californians. The Delta Conveyance Project aims to construct a 56 km tunnel beneath this delta, transporting water from Northern California to Southern California. The project kicks off near the community of Hood, about 24 km south of Sacramento. Here, 2 intake valves will be installed along the Sacramento River, designed to capture water efficiently. Each intake can handle up to 85,000 liters per second. The water will be filtered through fine screens to protect fish and other aquatic life, ensuring minimal disruption to the ecosystem. From these intake points, water will enter the tunnel, The tunnel will run parallel to Interstate 5, heading south. After approximately 72 km, the tunnel will veer west toward the Bethany Reservoir, where it will connect to the California Aqueduct. This aqueduct then distributes water further south to cities and farms, ensuring a steady supply where it's needed most. The tunnel itself will have an internal diameter of about 11 meters and be buried deep underground, between 43 to 52 meters below the surface. Construction crews will drill through layers of alluvium sand, silt, clay, and gravel. These materials lie beneath the soft soil and peat deposits that make up the marshy delta surface. One significant reason for constructing this tunnel underground is earthquake protection. The delta is crisscrossed with more than 1,600 km of levees, many of which are old and not built to withstand significant seismic activity. An underground tunnel would be far more stable during an earthquake. Engineers have designed the tunnel to endure significant shaking and prevent liquefaction, where the ground turns to liquid during intense shaking. The construction involves several stages, including site preparation, tunneling, intake construction, and connecting the tunnel to existing infrastructure. Throughout the process, environmental safeguards will be in place to minimize impact on local wildlife and habitats. Building this tunnel would be a significant engineering feat. Large tunnel boring machines, TBMs, will be used to drill through the earth. These machines are like underground factories. They cut through rock and soil, transport the debris out of the tunnel, and build the tunnel lining as they progress. The tunnel will likely take about 12 years to complete, with TBMs moving methodically, carving out the tunnel at a consistent pace, ensuring the structure's integrity as they go. The project also involves constructing 3 new intakes, each with a capacity of 255,000 liters per second. These intakes will be equipped with advanced filtration systems to ensure that only clean water enters the tunnel. The total annual yield from these intakes is expected to be around 6 billion cubic meters of water, a substantial contribution to California's water supply. In addition to providing a more stable water supply, the tunnel could help manage water during extreme weather conditions. With climate change causing more erratic weather patterns, having a system that can capture and store excess water during wet periods is crucial. This captured water can then be used during dry spells, helping to stabilize the water supply for millions of Californians. If operational during the winter of 2021 to 2022, the tunnel could have captured an additional 291 million cubic meters of water. To put this into perspective, this amount could supply 3 households for a year. This extra water would have significantly increased water allocations for 29 agencies dependent on the state water project. In 2023, during heavy storms in January alone, the tunnel could have captured an extra 281 million cubic meters of water. This ambitious $20 billion project represents California's latest effort to balance its diverse and often conflicting water needs. By providing a more reliable water supply to the state's arid regions, it aims to support both agricultural and urban demand while striving to minimize environmental impact. This project marks a significant step in securing California's water future, leveraging advanced engineering to overcome the state's unique geographical challenges.